Oh no. And in the front row.
Right. Good morning again, everybody. Perhaps if you get yourself seated. Before I introduce the next speaker, who should be well known to many of you, I have to go through the standard format. The emergency escapes are the two doors. Follow the signs for the fire escapes. The meeting point, if the fire alarms go off, is outside in the car parks where you should all go out and gather. Stop waving, Graham. He's been on too many flights going to standards meetings. There's no recording of the lectures allowed, either video or audio, except the official recording. And please switch off your mobile phones or put them onto silent. And without further ado, I'll pass you over to Graham Shirville, who is going to talk about the new world of amateur satellites. And as VHF manager, I get a little insight to some of the things that are coming up by the various discussions at the IARU meetings and things like that. And I think that, as a pre-warning, amateur satellites in the next 2 or 3 years will drastically change.
Hopefully.
Radio. So Graham, over to you.
Thank you, John. Firstly, could I just do a quick sort of straw poll? Who here already operates on amateur satellites? Right, okay, so quite a few of the already converted. Who didn't put their hands up last time operates on VHF? And thank you, and do we have any HF only operators here? A few, so you're all welcome. And who here is employed in the space industry? Good, okay, fine. So the agenda for this morning, a very brief history, just to remind us what we have done in the past, because there have been some great successes in the past, goes back a long way. Current activity, what's up there and available to work at the moment, and then moving on to the interesting bit for the future, what's coming up or going up, perhaps is a better expression. A reminder that the very first Oscar satellite, Oscar 1 as it then became called, Oscar standing for orbiting or orbital satellite carrying amateur radio, was launched in 1961, which is about 3 years after Sputnik, or 4 years after Sputnik was first launched, probably only 3 years after the first American satellite went into orbit. It replaced the lump of concrete. When rockets go up, they have to be balanced, so there was a mass, the dummy that needed to go there, so they replaced the small lump of concrete with Oscar 1. It operated for a few days or a few weeks on battery only, obviously, because solar cells then were really esoteric and not readily available, and it transmitted a beacon on 2 meters. Oscar 7, not a very big number above Oscar 1, launched in 1974, carried 2 transponders, a mode A, 2 meters to 10 meters, and a mode B, I think they called it, which was 2 meters to 70 sems. That satellite continues to work. It failed, the batteries failed, NICADs in those days, of course. After just a few years, it all died, and then about 10 years ago, it was heard from again, and it is still working now. Remember, then there were no chips, there were no microprocessors, there were transistors, there were no array, so it's working on hand-wired, hand-soldered transistors connected to capacitors and resistors, etc. It only works in the sun, obviously, because the batteries are now open circuit. What we think happened was the NICADs, the individual cells went short circuit, took the supply bus down to 0, and then something broke. A wire broke, a solder joint broke, whatever, or the cell actually decomposed, so it became open circuit. So the bus, when the solar panels come on, can now run the satellite. If you shout at it too loudly, you can stop it, because you can make the transponder take too much current. So there's a big issue of people running too much power up. At the moment, for the next month, it's available 24/7 because it's in continuous sunlight. It's about a month this year and about 6 weeks next year. And there's a timer that says, if I don't get a command from Earth in 24 hours, I'm going to switch to the opposite mode. And that timer is still running. Unfortunately, one of the capacitors in the timing circuit has dried out a bit, so the 24-hour time switch is now at about 23 hours and 52 minutes. I'll show you where to go and to check on the current operation of Oscar 7. It's also quite high up. It's probably about 1,200 kilometers. So it's quite a high low Earth orbit. That means you get a better coverage. So it's worth working. The largest, rest in peace, the largest satellite that amateurs have ever launched was Oscar 40, launched in 2000, went up on an Ariane 5. 450 kilograms was the wet mass with all the fuel on board. It had a number of events, situations, and difficulties when it was working. Who here's worked Oscar 40? Yeah, quite a few of us had wonderful times. Obviously, GTO right out to 35, because the onboard rocket carried on burning for rather too long, the apogee, the highest point, was supposed to be about 35,000 kilometers. It turned out to be about 60,000 kilometers. So it went out an awful long way. It is said that if that motor had burnt for another minute and a half, it would have actually left Earth orbit. So that would have been the first amateur satellite to leave Earth orbit. So it didn't last very long, but it did actually show us what can be done with amateur satellites in the microwave band, because the S-band downlink was tremendously strong. And people also experimented with the 5.6 gig, and I think it had a 10 gig downlink as well. No, it hasn't been heard of for a long, long while. So sadly. The latest one, as of a couple of days ago, LO87, AMSAT Argentina, carries a UV linear transponder. U in this context is UHF, V is VHF. A linear transponder. It's a payload. A lot of amateur satellites have been payloads on bigger spacecrafts. The benefit of that is that you get a free power supply, which is probably quite considerable in available volts and amps, and you probably get a stable platform as well. So that's the latest one. We're rather hoping that they don't launch any more until we get the next FunCube up. So we've already got AO73, and the next one would be AO88. So we could have 73 and 88, but I'm not sure we're going to achieve that. So current activity as well. For those that don't operate satellites, this is how you can do it. You don't have to be a big American guy, but sorry, Drew, if you're watching or if you see that. But it's fairly simple. These are commercial antennas. They're called arrows because they're actually built from arrows, from bows and arrows. And you can see here somebody's mounted it on a tripod with the transceivers, two handheld transceivers actually at the back of the boom. So that helps sort of carrying the bit. It's quite fun operating like that. You do need to have a recorder running to keep track of the QSOs you've had and the reports you've given, because you can't do that and write the log up at the same time. Tracking the aerial, tuning for Doppler, and writing. No, it doesn't work. But that's Wouter Jan, a Dutch radio amateur, taking it easily. Serious ground stations. Well, they don't need to look much bigger than that. I think that one's Mike G0MJW. I found that photograph. If it is his, I give him credit for the photograph. Thank you very much indeed. So they're across 10 element on 70SEMs, and I don't know, it's across 19 or something on UHF. Usual VHF, UHF things apply. You need very good filtering to get rid of all the QRM. You need nice masthead preamp to get rid of any losses in the receive side. So the only difference, I suppose, is that generally it is much better to use circular polarization because the majority of satellites now have linear polarized transmit and receive aerials, but certainly a lot of the CubeSats don't have active attitude control, so you can't be certain of what the transmitted or the polar diagram of the satellite antennas are. So circular polarization, whether it's left hand or right hand, is a benefit. And I'm not sure that's the current antenna at GB3. It is? Yep. Okay, that's the National Radio Centre GB3 RS at Bletchley Park. And that works more than adequately? Good. But again, local noise, certainly on 2 meters and on 70, is a big issue. Lots of software available for turning those aerials and tuning the radios. This is called PST Rotator. It's a guy in Romania, I think, who has written this software, a guy called Kodrat, and he updates it, and somebody asks for an update, and about half an hour later there's another update. So its only difficulty is keeping up to date with the changes. There's a long-term one, much more long in the tooth thing called Nova. Again, these can give a display of where the spacecraft is, do the predictions for you, download the orbital data, and tune the radio and point the aerials. As long as you've got enough COM ports and USB to COM, all those sort of issues exist. But and our homegrown Simon GK4 ELI, to give him his current call sign, is busy writing SDR console ver3, and that has got a satellite module about to be launched, which will enable SDR radios to work and to tune the SDR radios and to point the aerials as well. So moving on to the first game changer, something called CubeSats. About 10 years ago, well, probably a bit longer now, 12 years ago, a couple of American professors developed or designed a standardized small satellite called a CubeSat. Originally, it had to be less than 1 kilogram in mass, and it's 10 centimeter cubes. One of the guys is a radio amateur. At least he's got a call sign. He's not a particularly active radio amateur. But CubeSats, very small, as electronics has miniaturized, it's enabled low power, very small, and as battery technology has improved, that's what's made these sort of things possible. 1U is a 10 centimeter cube, and as I said, show there, 2 and 3U ones are possible. The benefit of them, or one of the benefits of them, is that they can be very simply deployed from a pod, which is just a box with 1, 2, or 3 of these CubeSats. A command is sent up, the door opens, and a spring underneath pops the CubeSats out at about 1 meter a second. So that's very simple. It says there more than 500 have been already launched. That's probably a duff number. It may be nearer 600 now. Quite often, you read of a sort of macro deployment of 20 or 30 coming from the ISS. A lot are deployed from the ISS. A lot are deployed as multiple deployments from other rockets as well. We were hoping that there was a SpaceX, well, there is a SpaceX launch scheduled to be launched from the States, not Cape Canaveral, but from the west coast, that should have had about 50 on. So that's going to be a macro launch. Unfortunately, SpaceX had a small event when one of the rockets they were launching or about to launch, it was fueled and it exploded, which is terrible for them, terrible for the client who had a £280 million spacecraft sitting on the top, and terrible for the rest of us because that's put everything back and delayed everything. But I'll mention that again because there's another spacecraft that we've got that's supposed to be launching on a SpaceX rocket. So more than 500 have been launched. Massive number, really. I mean, in comparison with normal satellites, which are 1 or 2. There's still about more than 1,000 being developed, not obviously all for amateur radio, but for commercial, Earth observation, educational training, some defense stuff, everything really. And some are now going beyond, or they're being talked about to go beyond Earth orbit. There's an American project that's taking 2 or is it 4 to Mars with them as secondary payloads, and they're going to pop out when they get into Mars orbit and act as a communications network. The other point is that it's not just the usual suspects of Russia or America developing all these and launching them or wherever else. It's more than 40 countries now have got satellites in space which are CubeSats. One of the things you will probably read in the press, and some of the professionals in the space game get very upset about, is space debris generally, and it is something to worry about. We can't ignore space debris. The more that goes up there, the higher the risk that, although space is a very big place, that two might come together. And You can see here the number of objects in space. This is 2015, 2010, 2005. These two big jumps were where, I think the first one was where a Chinese rocket was deliberately sent up to explode next to a dead Chinese spacecraft, and it caused that debris cloud. And this was a debris cloud, I think, caused by a disused Russian rocket hitting an Iridium spacecraft. So you can see those two big jumps. The point, actually, of this graph or slide is to show down here are the CubeSats. So adding CubeSats even to sort of 100 a year or whatever is not making much difference to the overall number of objects in space. A large number of the CubeSats are, as I mentioned earlier, launched from the ISS at about 400 kilometers. Their life in space, depending on the solar activity, we all depend on solar activity. Here, the more solar activity there is, the more that the atmosphere expands, and that brings satellites down more quickly. But normally about a year, depending on the ballistic coefficient of the spacecraft. So anything that's deployed from the ISS is not going to stay up there for very long. So a very quick overview of FunCube. FunCube 1, a 1U CubeSat. We designed it to be very simple. It was originally called KISS-Cube. We developed it as a joint project between AMSAT UK and AMSAT NL. What we didn't try to do was to try and do everything. We worked within the limits of our skills, whatever. So we manufactured 4 of the boards, but we bought in the structure, which had already been flight tested, the antennas, the EPS, and the solar panels. And I'm pleased to say it's all still working. It was intended always as a dual-use spacecraft for education outreach to schools to encourage kids to be interested in primarily in STEM and space and also radio. And it has it has a transponder on board as well, which comes on when the spacecraft is in eclipse, on the basis that if it's dark up there, it's dark down here, and probably the schools won't still be active, so we'll have our transponder on because we've all come home from work. That sort of works, except where we are in the UK in the summer, where we're far enough north for the satellite almost never to be in eclipse during the summer. So we manually have it switched at the weekend, so it's continuously in transponder on mode. Telemetry is still running, but only about 20-25 milliwatts, although that's well strong enough. Last night, the normal operation of changing it from autonomous mode, where it switches daylight to eclipse, to being permanently in amateur mode. It's normally Friday evening, somebody changes it. Unfortunately, the person who was changing it last night hit the wrong button, and we operated in safe mode, which we've never done since launch for one orbit till he got it right. But I can tell you that the safe mode transmission power output is only 22 milliwatts, but you can still get the telemetry, thank goodness. And there we go, that's another story. Anyway, right, robust signals, good link budget, yeah, I think I've said that. It was launched November 2013. It's celebrating its 3rd birthday. People tell us that if your spacecraft keeps working for a year, it's going to keep working for a very long time. Fingers crossed. So after 3 years, we're quite proud of it. Certainly one other person in the room who was there. This is just us having celebrating a successful launch at NRC. RSGB very kindly allowed us to take over their ground station for a couple of 3 days. So, as I've said, it autonomously switches from education mode with a high-power beacon to amateur mode with a low-power beacon during darkness. So I think I've probably said all that. The one downside that we did discover is that the frequency stability of the whole transponder chain is not really very good. Obviously, one of the difficulties, one of the challenges with CubeSats is power budget, power budget, power budget. How much energy you're going to get off the solar panels, how efficient the EPS, the power system, is going to be, and how much power you've got. So one of the design requirements was to use minimum power throughout the whole system. So we have maximum power available for the transmitter. So that meant the oscillators are very stable, very reliable, but thermal performance is rubbish. not rubbish, but we have to say that have to note that internally in the spacecraft, the temperature is going changing by 25 degrees every orbit. So it's going up 12.5 and then back down 25. Back. So the thermal situation on board is fairly extreme. In fact, my suspicion is that if it stops one day, it will be because a solder joint somewhere inside has broken, because that thermal cycling, I think, is going to make it struggle. As well as designing all the software and hardware for flight, we also produce the dashboard, which users can load on their computers. You can receive the signals with either a conventional SSB type VHF receiver or any of your favorite SDR dongles. In high power mode during the day, you only need a turnstile. I've also decoded it with a handheld, with a small whip. Anything bigger than that, and the signal becomes diabolically strong. Here's a plot that's about 40 dB above the noise there, or something like that. Narrow sidebands, though. So that's some of the telemetry. There are about 50 channels of telemetry, real-time and whole orbit data. It also does graphs. This is a total panel current. This is solar panel current. So here we are over here in sunlight. The panel current is 300 milliamps. And then suddenly we go into eclipse, 0. And then we get back into sunlight. But then there was, anybody remember what that is? Yeah, it was the last solar eclipse. We managed to catch it. It was somewhere over North Atlantic. Brilliant. Really shows it. We also have the warehouse, the online warehouse. So even if schools haven't got their own receiver, they can still get the telemetry. It shows who's received the telemetry. It shows some of the actual channels of telemetry. And never, is this going to work? This is real time, absolutely real time. Look at that. Online, demonstrated. It's currently, the last provider of data is JR2, so it was somewhere over Japan at, 4 or 5 minutes ago, 11:03 UTC. So it's still working fine. It's in eclipse. The battery volts are 8.13 volts. So it's a lithium-ion battery. The battery volts since launch have never been below 8 volts. So our power budget we got completely wrong, in the good way. We think we discharge the battery by about 7% each orbit, and then it recharges in about 12 minutes. So that was really good. Come out of that. Oh bother! I knew that was going to happen. I'm sorry. Trying to be too clever. Yeah. So the warehouse also has graphs. Whole orbit data is something that we developed fairly early on and has been really useful. This is a graph that shows there's a black and a silver strip on the outside. Actually, this is on the chassis. The CubeSat's got sort of a frame. One part of the frame we made black specifically. That's the normal part we made silver. There's something called Leslie's Cube. Probably some of us are old enough to remember Leslie's Cube experiments. I'm not sure whether it was O-level or A-level physics, where black things get hotter and colder quicker. Well, you can see here that the silver strip, which has got, let me get this the right way round, the silver strip has up and down temperatures, but the range is not as great as the blue ones, which are obviously the black strip, as it happens. Here, that's in the sunlight. This is the satellite gently rotating round. Talk about rotation later. And here is in eclipse, and you would expect all the heat to dissipate into space as it's getting colder. But just here, there are little bumps here. It's starting to get colder less quickly. And that's when those faces are facing the Earth, and it's the infrared radiation coming back off the Earth that's holding the spacecraft temperature up a bit. I'm describing this because this is the sort of science stuff that we hope that teachers can use. I didn't talk about the one on the right. Why didn't I talk about the one on the right? Whole orbit data, battery voltage I mentioned earlier. Here the battery gets down to about 8.1 at the end of eclipse, shoots straight back up in the sunlight, and if that's the time it's taking to charge the battery, it's sort of 10 or 12 minutes, depending on how much the transponder's being used. Further analysis. What time of year is it summer in space? Summer in space? Well, we're not actually in a circular orbit. Our orbit is around the sun, is slightly elliptical. At the moment, here we've got the higher temperatures around Christmas. So that was just after launch, and we've got almost 2 years data there. And you can see that these are the maximum, average, and minimum temperatures of the RF board. So that's an internal temperature. So there's something like 7 or 8 degrees, the spacecraft is 7 or 8 degrees warmer in winter. So we talk about space summer and space winter. People don't understand what we're talking about, but never mind. Other interesting graphs, very simple spacecraft. We said it doesn't have active attitude control, magnetorquers, wheels, sun sensor, or it has got sun sensors, but star sensors and all that sort of stuff. That would take too much current, too much power to actually measure it, to do the attitude determination, and to actually control it then would take even more power. So we have a magnet and a couple of hysteresis rods, so it should line up with the Earth's magnetic field. Our spin rate has varied day by day quite considerably. This is something like 1 rotation every minute, down at about 60 seconds per rotation. Out here, gets up to about 60 minutes, and you can see the variation there. A couple of times more recently, it's actually flipped and started to go the other way, and then, oh God, no, I'm not supposed to rotate this way, and then it's sort of gone to 0 and gone back. So that's a definite unknown. If anybody is involved with space and would like to try and work out what is happening, we really don't know. Whether it's we think it's currents being, or magnetic fields being created by currents flowing through the solar panels or down the stack, but we're making it up a lot. It does seem to be gradually getting slower. The peaks and troughs seem to be getting slower or lower, so maybe it's going to settle down in an equilibrium. So, AO73 technical overview. I've mentioned the frequency stability due to the internal temperature changes. The power budget is really brilliant. Hope we can do that again. Link budgets, again, really brilliant. You can hear it with a piece of wet string. And there's no evidence of any radiation damage. That was obviously one of the things we were particularly worried about. It's rebooted, I think, 5 times since launch, 2 of which were operator error. So there's only 3 that God has done to us. And there's no, well, we know of 1, actually it says no bugs in the flight code. We are aware of 1, but it's not critical. So we're quite proud of that. But it is very simple. Just a very brief legal review. There's quite a lot of legislation that relates to launching things into space, as you can imagine. One of the difficulties we have in this country is that there's a lot of, the UK Outer Space Act has some very stringent requirements of who can launch or own a spacecraft, and requires third-party insurance, which is very expensive. So before launch, we actually sold this spacecraft to AMSAT NL in the Netherlands for €1, and their legislation is similar to ours, but is not quite so severe in terms of the costs. So it costs AMSAT NL something under €10,000 a year for their license, which we are helping them pay, of course. So the next FunCube was on UCube. It was a payload on a British spacecraft called UCube. As I said, it was actually built up in Glasgow. It's a slightly old photograph. You'll recognise that was the First Minister. And we think it was launched with a Scottish Solitaire on it. But anyway, Scotland's first spacecraft. You heard it here. So it was announced that the end of mission was announced in October last year, and it has got a transponder and it has got telemetry on it. Now, unfortunately, the main onboard computer, or the system on board, for reasons that we don't fully understand, reboots 7 times an orbit, which makes command and control and operation of the spacecraft quite difficult. But currently, randomly, the amateur transponder comes up every time it reboots, it restarts. So the transponder is always on if the satellite is active, and it is now in regular use, but we've got no control over it. So that's a second FunCube. Third FunCube is another payload on QB50P1, really exciting title. There is a mission for 50 CubeSats to do ionospheric and thermospheric research in very low orbits. It's a constellation, I think is the right word, of 50 CubeSats, which should have been launched this year, hopefully will be launched next year, and which will be using frequencies of the amateur satellite bands. Partly as a thank you for organizing that, they've let us put a payload on this particular one, which is much higher up at 600 kilometers. They again have finished with the main mission for that, so we're working with ISIS, who are the Dutch operators, to develop an operation mode where we can use the transponder. That will be a transponder only. Their power budget is not as good as FunCube's, so they're having to load some new software. They can upload patches. So as it says there, real soon, I would guess by the end of this month, early next month, we'll have a third transponder. These are all UHF up, VHF down transponders, and really easy to use. Existing transponders, lots of them. The two there at the top are fairly recently launched Chinese ones. You will, in some literature, see other ones referenced. The other ones do not satisfy the requirements of the IARU Region 1 band plan, so please do not use them. Right, John? They shouldn't be switched on over Europe. And here are the older, more elderly ones, FO29, and as I mentioned right at the beginning, Oscar 7 and the Mode A and Mode B. Oh, blimey. I again hit the wrong button. I missed it completely. Too much excitement going on in my life. And there are two FM transponders at the moment, a fairly recent one, AO85, which is quite strong. Saudi Sat 1C is a bit more, it's a weaker transmitter, so it's harder to hear. But lots of people use SO50 and AO85. Again, simple handheld radios will work fine as long as you've got the tones. I mentioned right at the beginning that it's easy to find out what spacecraft are going on, which ones are active. The ones that are blue have got the transponders on. Users are encouraged to fill in their own reports. That's it's like a DX spot, I suppose, but it was created many years ago, which is why it doesn't look terribly pretty, I guess. Right, coming up or going up. So this is what John was asking me to really talk about, I guess. But before I get on to the microwave ones, Naif 1, another 1U CubeSat. So there's an awful lot of them. This one's being funded by the Emirates Institution for Advanced Science and Technology. Again, it should have been launched by now, but it's scheduled to launch from Vandenberg on a SpaceX rocket, which is now, that work stopped until they find out what went wrong on the previous mission. It will be like FunCube 1, but it has got an active attitude control system. It's got higher efficiency solar panels, so hopefully our power budget will still be okay. It's also got upgraded oscillators, so you will not be able to tell that they are drifting, because they don't. Well, no more than about 1 or 2 hertz, so if you can measure that. And fitter messages, we have greetings messages that we put up. We've redesigned the software so that it will work in Arabic. Here it says it's going to be launched on a SpaceX flight. AMSAT NA have got 2 more CubeSats being scheduled, which are scheduled to be on the same flight. Those Fox 1C and D are both FM spacecraft. Slightly elliptical orbit, or fairly elliptical orbit, so the apogee is higher, so the range will be better. As it says there, launch date was 2016. We'll pass over the deployment test, because it's only aerial sticking out. Next mission, we're now getting on to some microwave stuff. Well, not microwave, 1.2 gig uplink. That isn't microwave, is it, properly? But our longest project, we started in 2006 on something called ASEO, the European Student Earth Orbiter, which is what it says in the tin, is a microsatellite. where we're now putting a payload on, and we've got to the engineering model stage, which was delivered to Italy a couple of weeks ago, and a team, including David, who's probably not in the room, but there's 3 guys from AMSAT UK going over there next week to answer all their difficult technical questions and interface questions and CAN bus questions, and to convince the Italians that it's good enough that when we make the flight model from this engineering model to fly. So it will have an FM uplink on L-band with an FM downlink for the voice transponder. It will also have the BPSK FunCube type telemetry with FEC that we're used to, but we're going faster because we've got a bit more power. So it works very nicely on 4K8 and it whizzes across the screen. And those of you who've heard the signals from FunCube know it's got a sort of 5-second beep every 4.7 seconds. Actually goes beep, and then a burbly noise. Well, this is like a sort of angry hornet. I won't try and, but it goes 4 times faster. But it is, again, very distinctive when you hear it. Further work's being done. There's another spacecraft that we are working on, hasn't been finalized yet, but it's JY1SAT is its acronym. That will tell you where it's coming from, where it's being financed, or where the project lead is. Again, we're looking at a FunCube 1 type system, but with some stored image downlinks. What we're hoping to do is take SSDV, this digital slow scan, it's not slow scan, but digital slow scan system that's being used on a lot of high altitude balloons, and we're going to take that into space. The developer of the systems is very keen to get it from near space into real space. Possible launch next year. But the next game changer, after CubeSats, the next game changer is SHALE-2. That's what AMSAT people call a phase 4 spacecraft. That means it's geostationary. Now, I think we all know that means it stays effectively in the same spot, or appears to stay in the same spot in the sky, so we don't have to worry about rotators and pointing. Once we've found the wretched thing, it stays in the same place. Just a quick reminder about radiation belts. LEO is is below the radiation belt, so we're fairly calm there. MEO, which is an orbit that we would really like to be in because of the range, there are 2 radiation belts, 2 Van Allen belts. Most MEOs go in between the 2, but the radiation level is still higher. GEO is actually above all the radiation as well. So not only does it have the advantage of staying in the same place, the radiation levels are still higher than LEO, but not extreme. So the coverage, as you would expect, this is it's expected to be at 25.5 degrees east. I think if we watch Sky, we're watching a constellation of 3 or 4 Astra spacecraft that are all nominally at 28.2. So it's within about 2 degrees of where your sky dish is pointing. So everybody can go, I know where the sky dish is pointing. Is there a tree in the way, or a house in the way, or a lamp standard in the way? But it will be pretty well in exactly the same spot. The Americans miss out. Sorry about that. You can be just at the edge of the range in Brazil and over here in Kuala Lumpur, and I'm not sure quite about Singapore, but that's the sort of range. And obviously north and south as well, so a massive coverage. Now, this is using, just talking about the antenna gain. It's got what's called a global beam in satellite comms terms. So the antenna gain cannot be more than 20 dB on the spacecraft. But this hasn't said it yet, but it's S-band up, 2.4 gigs up, and 10 gigs down. So this is almost real microwave stuff. The link budget, somewhat difficult to be precise, depending on whatever. They're taking a standard downlink TWT channel that is designed to operate from 10.7 to 12.5 gigs, and we're operating it just below 10.5. So there's some derating of the TWT. It's going to be a non-inverting bent pipe transponder, so whatever goes up comes down. There are 2 transponders. There's one that's 250 kilohertz wide only. So this satellite that's got all these TWTs that are used to spreading their power over 30 or 40 megs for one channel of DVB-S2. All that power is going to be concentrated on 250 kilohertz. So that makes up for the fact that you're used to a spot beam, and now you've got a broad beam, a global beam. So the link budget's going to be pretty good. I'm not sure that you'll need a sky dish, but there you go. 5 minutes. So 5 watts, 10 watts PEP output uplink for the S-band. Wideband transponder is 8 megs wide. So how many TV channels? You heard Noel talking earlier about reduced bandwidth television. How many TV channels can we get in that? Quite a lot. Again, I would urge caution for the link budgets to the absolute degree. Do I need a 90 centimeter dish, or whether a 60 centimeter dish will be? We will find that out. That's just a band plan that shows where the different frequencies are, which the polarizations are for uplinks and downlinks, and for which transponder. So that's going to be an amazing game changer, I believe, in terms of the use of microwaves by radio amateurs in IARU Region 1. And we can just imagine all the islands on the air, summits on the air, all the competition going on, that's all the boats sailing around. Anyway, moving rapidly on. Also, I mustn't forget Fox, the other Fox is the CubeSats being built by AMSAT NA that I've mentioned briefly, but they've also got 2 more coming up that are linear transponders. And almost finally, AMSAT UK are also thinking about working on other projects, having imagers, having upgraded MCUs, maybe HF bands, and medium Earth orbit ride shares, etc. One I'm just going to briefly mention, though, is Lunar Communications Pathfinder. This is a project that's being put together by Surrey SSTL and the Goonhilly Earth Station company to launch, or have launched, a 500-kilogram spacecraft into lunar orbit. This is real. Well, it's as real as projects get at this stage. That will then deploy some CubeSats up there. But maybe we could have a payload on the mothership that could act as a transponder, or have a transponder that radio amateurs could use. It could be used for ranging, so the owners can work out precisely where the spacecraft is, and also very low data rate signals going direct to schools for educational outreach. Lots still to be think about that, and I have to say there are lots of other opportunities that seem to be coming up. So conclusions. Amateur satellites are growing in number and type. They support a wide range mixture of activities. There are lots of new operators joining. We can share amateur radio and STEM outreach. That's, I think, a key that we should be trying to maintaining and continuing to do. The bigger challenge is to find the volunteers, but there is lots of exciting stuff coming up, and we have lots of fun. And please join AMSAT UK. 2 radio amateurs outside number 10 last month. Brilliant.
Thank you, Graham. We have time probably for one question. Go on. You've won the pile-up, Paul.
Thanks. You mentioned the various downlinks for being horizontal or vertical polarized. Surely you're going to get some Faraday rotation in there, so you're not really going to know whether it's what it's going to be when it gets down.
If you're talking from the LEO satellites, yes, exactly. Yes. So the satellite is rotating itself, and Faraday's doing its stuff. And we have on 2 meters, we have lots of ionospheric effects, ionospheric scintillation, which changes everything.
So I will say you still throw away 3 dB, and you actually ought to take a tip out of other people's books, which is actually use a dual SDR and digitally combine it. Which is, if you push for dBs, that's what you have to do.
I will take your advice.
Thank you very much for that, Graham. On the agenda this afternoon, there's a slight change. Unfortunately, Ian GM3SEK is sick, and I talked to him yesterday. What I have done is I've substituted the talk that I will be giving tomorrow morning as well as a pre-run, the same talk twice, which is about microwave links for remote stations. But what I will say within that is it does involve some 2.4 gig engineering with small dishes and 5 or 6 watts out, so might actually provide some technology for an uplink. So I won't hold you because you've got to get away to lunch. We reconvene at 1:45 for Professor Olwyn Seeds talking about what to look for in a VHF UHF radio. But before we go, can I ask you to thank Graham for his expose of satellites again.